Rudram anti-radiation missiles to silence enemy air defenses. Modern air battles are won by those who control the electromagnetic spectrum. India's Rudram family of anti-radiation missiles exists for that fight, finding hostile radars, flying their beams back to the source, and tearing holes in surface-to-air missile belts so strike aircraft can get through. Here we explains what Rudram does, how it hunts, and why it changes the calculus for enemy air defenses. Begin with the kill chain. Air defenses work by emitting energy, search radars scan, engagement radars lock, and missile seekers guide. Every emission is also a beacon. Rudram's passive wideband seeker listens for those radio frequency signatures, classifies them against a preloaded library, and fixes bearing and, with geometry, position. That library, built from intelligence, exercises, and recordings, lets the missile tell a long-range surveillance radar from a fire control illuminator and pick the priority that most disrupts the enemy's shot sequence. Targeting modes map to real scenarios. In programmed, pre-briefed mode, a Rudram is launched toward a known emitter location to arrive when a strike package needs a corridor opened. In reactive mode, the launch aircraft detects a pop-up radar and cues the missile immediately. In self-protect mode, a fighter under threat fires to force an enemy radar to shut down or pay the price. Home-on-jam logic flips the script. If the defender jams, the missile can ride that energy too. Guidance blends autonomy with updates. Inertial and satellite navigation fly the mid-course efficiently. The passive seeker refines the fix as the missile nears the target area, correlating pulse patterns, frequencies, and scan rates to avoid decoys. If the radar switches off, Rudram doesn't go blind. It can continue to the last good coordinates, search with a sector scan, and hit the radar van or its generator and cables, damaging the node and the crew's confidence. When the defender lights back up, the seeker snaps to it in milliseconds. Kinematics and profiles are tailored for survival. Solid propellant motors and efficient airframes give high average speeds and altitude-flexible trajectories, lofted for range against deep emitters or direct sea-skimming approaches for coastal sites. Programmable fusing and optimized warheads create fragment patterns that shred antenna arrays, electronics, and exposed waveguides. Against mobile systems, time to target and terminal agility matter as much as raw range. Rudram aims to shorten the defender's window to move or decoy. CAD becomes dead with timing and numbers. A single missile can force a radar to shut down, but a timed pair or salvo can bracket the defender's choices. One to compel silence, another to arrive when they feel safe to re-emit. Coordinated attacks layer effects, decoys to trigger emissions, jammers to raise noise floors, and Rudram rounds to smash keynodes. When radars hide behind terrain, fighters and AEWNC provide geometry for lofted shots that clear ridgelines and drop in steeply. The launch platforms make the system. Integrated on frontline fighters with modern electronic warfare suites and data links, Rudram benefits from better detection and queuing. A fighter with an ASA radar and passive receivers can classify threats, assign priorities, and hand off mid-course updates. Mission data files, those emitter libraries and waveform profiles, are the software brain. They evolve with every exercise and real-world recording, pushing smarter logic to the next sortie without changing hardware. Defenders do adapt. They use emission control, relocate often, deploy decoy emitters, and field digital radio frequency memory jammers. Rudram's counters are in seeker agility, signal processing, and tactics. Prioritize fire control radars rather than noisy search sets, attack generator trucks and communication vans when radars go dark, and pair missiles with loitering munitions that can wait overhead until the enemy must radiate again. Even when a physical kill is not achieved, forcing radars to cycle off at critical moments degrades missile guidance and breaks the engagement chain. Doctrine changes when an air force trusts its anti-radiation weapons. Strike packages can thread narrower corridors. Fighters can sanitize approaches for AWACS and tankers, and coastal batteries lose the comfort of predictable sanctuaries. Over time, the pressure shifts the defender from hunting to hiding, which yields airspace in practice even before it is won on paper. Sustainment and sovereignty matter. Indigenous seekers, fusees, and propulsion keep the supply line under national control, allow rapid software refreshes as adversaries tweak tactics and permit tailored variants, longer reach for deep nodes, faster time to target for mobile threats, and seeker options that mix passive RF with other cues for cluttered environments. Range headlines are less important than probability of kill inside realistic timelines. That is where iterative testing and mission data updates pay off. Rudram converts enemy radar energy into a vulnerability. By turning emissions into targets and time into pressure, it opens the sky for the missions that follow: strike, escort, and reconnaissance, while raising the cost of any attempt to lock and launch against Indian aircraft. For deep dives on seed-dead tactics, seekers, and India's evolving suppression toolkit, visit globalinfoveda.com.